Good afternoon, everyone. This is Allie Mostardo, Association Manager of PPRA. Thank you for joining us today for the roadresource.org webinar, Engineered Performance for Pavements, Asphalt Emulsions. This is the fourth webinar in a series of 6 that are planned for this year. We do have you all on mute for the webinar, and we'll be using the chat function for any questions. Questions will be answered at the end of the webinar. A brief introduction before we begin. Lindsay Matoush is President and CEO, and Grace Stansberry is an account executive at Vario Consulting, the marketing firm that has partnered with PPRA to create roadresource.org. Over the course of the year, they will be presenting a series of webinars on roadresource.org. Brian Cancio of Russell Standard and Buzz Powell of NCAT will be assisting in today's webinar. We will now turn the webinar over to Lindsay and Grace.
Good morning, everyone. And welcome to our fourth webinar in this series on roadresource.org regarding engineered performance for pavements and asphalt emulsions. I'll quickly walk through the 4 people that will be your speakers today. You have as facilitators myself and Grace Stansberry. Grace and I work with Vario Consulting, and we are the thinkers, the strategists, and the developers behind roadresource.org. We are not industry experts, we're strategists, and it's been our primary job to do the work of listening to agencies to understand the questions that they have in using these types of treatments or managing their networks, and then to connect those questions with answers and resources. Joining us today to speak more about asphalt emulsions, we have 2 speakers. First, Brian Cancio. Brian is a research scientist for applied chemistry with Russell Standard Corporation. He's been in the industry for 11 years, and he assists the research development and deployment group with asphalt product formulation, application, and refinement with a deep focus on asphalt emulsions, cutbacks, and coatings. What we appreciate about Brian is his understanding of both formulation and the science that goes into engineering emulsions, as well as his understanding of application and how to connect the two. Also joining us today, one of our longtime favorites, Buzz Powell, who was instrumental in helping us understand and think through the goal of really closing the gap in research and practice and informing some of the sections on the Road Resource website. Dr. Powell is the Assistant Director and Test Track Manager for the National Center for Asphalt Technology. He's also the Senior Research Engineer, and he has spent the last 20 years working on the test track, and he brings to us incredible insight about the questions the industry is asking about different types of treatments and how their performance holds up, as well as a deep understanding of forensics and determining what fails and why. Asking all those questions and answering them appropriately is obviously such a critical part of the equation in helping agencies be comfortable in using a broad range of treatments to stretch your resources and your budgets further. So what are we going to cover today? We will talk about emulsions about them, how they're manufactured, and also how and why they are named what they are. When we talk to agencies, we get a lot of questions about that nomenclature. We'll also introduce you to the Resource Center on the website, where we answer many of the technical questions that agencies ask about emulsions and how to use them, store them, handle them properly. We'll share a little bit about agency improvements and how we see agencies using the performance that emulsions provide to extend the life of their pavement. And then lastly, we'll have the chance to hear from Dr. Powell about what he's learning about asphalt emulsions from the test track, and specifically talking about chat coat or bond coat, as it's sometimes known in ensuring pavement success. We always like to give just a few words at these webinars about how the website was born and who sort of commissions the work. So we have 3 separate associations that joined together in support of the vision for this resource. That is EMA, the Asphalt Emulsion Manufacturers Association, ISSA, the International Slurry and Surfacing Association, and ARA, the Asphalt Recycling and Reclaiming Association. They came together in realization that the industry was looking for simplicity and a simple, easy place to come and get their questions answered about all of these different treatments. They came together to form the Pavement Preservation and Recycling Alliance, which is driven in interest of helping agencies get better roads today, but link better roads today together for stronger networks tomorrow. The information at Road Resource is built together to drive towards a single promise. And that promise is to help agencies or to empower agencies to be the best possible stewards of their road networks and their taxpayer dollars. The tool at Road Resource has 500 pages of information, and as we sat with leaders to strategize the best use of that tool, every possibility was filtered through this lens of how it helps agencies achieve those goals. As we started the project, we did research with agencies all over North America. And we were interested in talking to decision makers at different levels of decision making at city, county, state, and provincial agencies in different climates, everything from state materials engineers to inspectors. We asked, how do you make choices about road treatments? What do you think about emulsion-based treatments, preservation, recycling, and what do you need to understand more of in order to be comfortable using those treatments to extend pavement life? And as we did that listening and that research, we were really able to connect with some what we're calling best practice agencies, or those agencies who are reversing the trend of deteriorating networks and making choices that help their networks gain ground. What we found as we talked to them was 4 real traits that were common to those agencies, and that is this. They used a robust toolbox of treatments and applied them appropriately. They didn't have just 1 or 2 or 3 treatments in their toolbox. They were comfortable using a diverse range of treatments. They approached their treatment plans each year in light of network level considerations. So they were thinking not just what am I doing with this road or this year, but what am I doing this year to help me gain ground next year. They drew upon the success and innovation of others in similar regions and clients. They were really paying attention to what other agencies were doing, were trying, what the industry was learning, what innovation was out there. And lastly, they were in touch with the industry at large. And a big part of that is research. So we're, again, excited to have Dr. Powell here today to share what he's learning on the test track. If you enjoyed what you hear today, we have 2 more webinars left through the end of the year, and we've done, as I said, this is the 4th in a series. So the first 3 focused on network topics and thinking. Those are all located on our website under the Resources tab. If you like what you hear today, on October 30th, we'll be talking about asphalt recycling and reclamation, how to get the most out of the pavement that you've already paid for. And we'll talk on November 20th about pavement preservation and some hot topics in that field. Mostly today what we're pulling from is the resources and tools available on the website roadresource.org. As I mentioned, there's 500 pages there. A lot to learn, but today we'll be focusing on the emulsion sections of that site. So without further ado, I'll ask Grace Stansberry to introduce our first speaker, Brian Cancio.
Good morning, everyone. Before we got started and diving into the website, we wanted you to hear from somebody who deals with asphalt emulsions and formulations and applications every single day. And so Brian Cancio has helped us out and jumped in here. And we thought, hey, it'd be good to learn a little bit about how that works. Brian, can you walk us through the top line a little bit about what a research scientist does and how you're involved with emulsions?
Sure. You guys can hear me okay?
Great. Yeah.
Okay, thank you. Yeah, so as a research scientist, as you guys mentioned earlier briefly, like my biggest concern is working with both the emulsions themselves and their applications in the field, because this is chemistry that goes out and deals with the very complicated reality of the world, and dealing with things like weather, temperature, roads, the raw materials that they're made of, calls for a lot of changes and a lot of factors to be considered. So the biggest part of my job is taking a formulation of a product, an asphalt emulsion, and making sure that it performs to the best of its ability when it finally gets out into the real world and out of the flask or the beaker that it came out of.
Great. Yeah, it's such an interesting process to us. Brian, when you're working with an agency, what are the major concerns or challenges that they face when using emulsion-based treatments? I know we had a little bit of a short list. Go ahead.
Yeah, go ahead. I think the biggest concern a lot of them have is when they hear the word emulsion, they're like, so what is that? Like, I get what asphalt is, I get what my road is made of, but when I'm getting involved with emulsions, what is that? And the biggest thing I always tell them is you're already using emulsions every day. It's a ubiquitous part of your life. You see them every day in food and mayonnaise and butter, at home in your paints and adhesives, and asphalt emulsions are no different. They're just another vital piece of your construction. The biggest thing to note about emulsions is really it's just an asphalt, which is like your oil, and the water that it's suspended in, and those two things together plus a little bit of chemistry gives you this stable, versatile tool for your construction. I think the naming conventions especially kind of overwhelm a lot of people. It's a simple matter of realizing that each of the letters you see in the given name of an asphalt emulsion is just an indicator of what the performance of that emulsion is capable of, whether it's cationic or anionic, whether it's rapid set for chip seals or slow set for recycling. It's just a simple matter of learning a little bit of the lexicon involved, and then it's as simple as glancing at an emulsion name and immediately knowing what you're supposed to use it for.
Fantastic. Do you ever find, we've also heard from agencies that sometimes they're not exactly sure how to handle emulsions as separate from other sort of paving treatments, or how you should treat emulsions differently. We sometimes get the sense that agencies wonder if emulsions are more finicky than other treatments.
I think in practice you'll actually find it's almost the opposite is true. When properly handled and maintained, emulsions are actually quite easy to deal with. It's just a matter of making sure you keep them with themselves. We generally recommend that people store and transport emulsions in tanks or trailers that are dedicated to that purpose, and that they try not to mix cationics and anionics. But really beyond that, it's a simple matter of treating it like any other pumpable liquid, and understanding that sometimes it may be hot and there may be some safety there, but other than that, it's no more dangerous, honestly, than some of the industrial paints you see. I think the big thing to consider with that would just be to heat and circulate your asphalt emulsions regularly where you can, and sample them regularly to make sure their consistency and quality is good.
Cool, thank you. Yeah, we're going to get into a little bit of that, how to handle storage and other considerations a little bit later on. But before we do that, I want to just go ahead and jump into the website really quickly. I'm going to take you all over there right now. So as you know, one thing to consider, the roadresource.org website is full of a wealth of information across many different topics on road maintenance and network management. And so we're just talking about one today under the emulsions category. If you're interested to know anything about emulsions, start here over on the far right side of the main menu. You can find a lot of that information here. So we'll start with a little bit about emulsions, some of that top-line information, which can be really helpful in framing a lot of the more technical and data-driven information that you need to know about emulsions, or when someone's talking to you about a concept. This is a great place to start. We'll go ahead and flip over here. The first thing to know is that emulsions have a set of unique benefits, and treatments that use emulsions have a set of unique benefits as separate from some of their counterparts. Typically, they tend to be lower cost or more cost effective per unit cost than their counterparts. And furthermore, emulsion-based treatments are often used in pavement preservation and recycling, which extend pavement life and defer maintenance costs later on. So tend to save costs in that sense as well. They're engineered for customized performance, which means that depending on what problem you're facing, a specific emulsion can address that head on, which means they can deliver increased flexibility or strength, rejuvenation of your pavement. They can improve moisture resistance, cohesion, durability, or chip retention, depending on what issue you're facing or trying to address. Furthermore, they are compatible. They can be engineered to be more compatible with the materials available to you in your area. Depending on the type of aggregate you're using, you'll need a specific emulsion. They're a little bit more versatile in construction, meaning they can be made at a remote or central site and then trucked to where you need to be, or they can be mixed during construction and stockpiled for later use. There are some emulsions you can store for extended amounts of time. And they're optimized for the job, meaning depending on when you need to be and where, you have a specific set of protocols to handle your emulsion, but you have a lot more flexibility there. Furthermore, emulsion-based treatments are safer because there are cooler temperatures than their hot mix counterparts with less flammable materials, which is safer for your workers. On top of that, faster construction times and faster return to traffic minimize exposure for your workers and also minimize delays for your driving public. Asphalt emulsions also tend to have better environmental benefits because they reduce and eliminate petroleum solvents and hydrocarbon emissions. There's less excessive heating, which is better for the greenhouse gas emissions, fewer fumes, which is ideal for non-attainment areas. And using emulsion-based recycling, you can reuse your existing materials and minimize trucking and hauling and transport, which we find all of that stuff really adds up when it comes to not only your bottom line in saving money, but also pays off a long way for the driving public. For them to see the environmental benefits tends to get people a little bit more excited about road maintenance. But to step back a little bit, Brian went into this. What exactly is an asphalt emulsion? We find that a lot of people are approaching it at this level. At its most basic, as Brian went through, an asphalt emulsion is made up of 3 pieces: water, an emulsifying agent, and asphalt. For the most part, all of that is rolled into one. There are a lot of other emulsions that use polymers and additives, but at its most basic, that's what it is. Asphalt suspended by an emulsifying agent in water. So when we look at what an emulsion is, it's important to know how it's made. Typically, an emulsion is formulated with these 3 components and then customized additives depending on what sort of performance you're hoping to get. And if you're interested to learn more about each of these steps, you can click to learn a little bit more about how they're done and what that means for the emulsion. So we take all that raw material and pass it through a colloid mill, which then gives us an emulsified material, emulsified asphalt. And Brian, feel free to jump in here at all if I'm getting the chemistry off. Emulsions have a considerable amount of water in them, and that suspension using that surfactant creates a homogeneous mixture for the asphalt particles to be dispersed evenly in the mixture. We'll go ahead and show that here. They're emulsified, and that's a little bit of an illustration of what's going on chemically inside that mixture. So from there, they can be put into tanks and transported out to the job site where they're applied. And first, once they're applied, they break at different speeds depending on the workability that you need from each of those treatments. And once they break, they're typically laid down brown, and then they break and cure, giving you that black finished product. Brian, did I get all my chemistry right? I imagine
that sounds good.
Cool, thank you. No, that's fine, thank you. So that's a little bit about what they are, what they do, and how they're made. And we still hear a little bit of confusion from folks when it comes to the emulsion naming. So we're going to head over here to emulsion naming and classification. You can find this on the website. Here we go, the second tab under the emulsion category. And so what's really interesting about how emulsions are named and classified, it changes a little bit from region to region, but they tend to follow similar naming conventions. And each name of an emulsion tells you about not only how it's designed to perform, what it's made of, but also the issues that it can address for you when you're facing specific problems or in a specific situation. The first thing to listen for when you're looking at an emulsion name is whether it's cationic or anionic. That's the C or the absence of a C at the beginning of the name. What that tells us, let's say we're considering a cationic emulsion. That means it's positively charged, and they're designed to break chemically typically. making them a little bit more compatible for nighttime and cooler climate applications. So there's a scenario in which you would need a cationic emulsion. Anionic emulsions tend to rely on evaporative breaking, their counterparts. There are also non-ionic emulsions, but they're pretty few and far between. You can also listen for more characteristics, such as high float. If you find an HF in the name, those are typically used in chip seals, cold mixes, and road mixes. And that forms a little bit of a gel and gives you a wider range to prevent flowing in hot temperatures and to prevent cracking in cold temperatures. The next characteristic that we look at in the name is whether there's an RS, an MS, SS, or QS, which tells us the speed at which the emulsions are set, which gives us a little bit of a sense of our workability on the project. For rapid set emulsions, these set up very quickly. They're the least stable. They're used in spray applications, typically like chip seals and scrub seals, and there's not a lot of ability to mix them with aggregates because they set up so quickly. However, medium set emulsions are used in cold recycling and warm dense graded aggregates, and they tend to remain workable for a range of time. Depending on what you need, could be a few minutes, could be several months. But they coat the aggregates during mixing and they break soon after, which allows you to use them in pug mills in different areas, things like that. Slow set emulsions are the most stable emulsions. It takes a long time for these to set up, and they're compatible with fine aggregates. They break typically through water evaporation. We see these used in slurry seals, soil stabilization, and some of those dense graded aggregate bases. They can also be, the slow sets can also be diluted with water to be used in fog coat, fog seal, and dust palletives. And quick set too, same thing, has a specific set of uses. They're often used in microsurfacing and slurry seal. So if you're curious about the speed at which an emulsion sets up or what kind of workability you need, that's a way to start. Viscosity and hardness is indicated a couple different ways with the 1, 2, an H, or an S. Emulsions with lower viscosity are indicated by a 1. They're more fluid. They're designed to flow into aggregate. Typically, those are used in penetrating primes and prime coats. Higher viscosity emulsions are thicker, and they're designed to really cling to that aggregate. They're used in mixing emulsions. If you see an H, that tells you it's going to be a harder base. It's thicker, less pliable, and they work well in warm climates because they're less likely to run with that thicker base. Softer bases are better in cold climates because they're more resistant to cracking. And then depending on where you are, you may see an L, an S, or a P, indicating whether there are polymers and additives in each of those emulsions. So next time you hear somebody spew out a little bit of alphabet soup saying CHFRS2P, you know exactly what that means. It means it's a cationic, high float, rapid set emulsion with higher viscosity and additive polymers. So a little bit of a way to sift through some of that naming convention that Brian was talking about that can be a little bit of a hurdle for many people. So with that, we're going to jump back over here, and Lindsay's going to walk us through a little bit of how agencies are using emulsions in different ways.
Thanks, Grace. So we're excited to see once agencies get comfortable using emulsions and recognize that it is engineered performance that they can rely on, we see them using emulsions and emulsion-based treatments in some pretty powerful ways to stretch their resources further, to gain ground on their network, to use different treatments, and to appease taxpayers. So, Brian, I'd love you to walk us through just one case study. There's many case studies or success stories on the Road Resource website, but we asked Brian to pull an example that he found interesting. So why don't you tell us, Brian, what you're seeing in Trumbull County, Ohio?
Sure. So Trumbull County, Ohio was already maintaining a very successful chip seal program, but they always had a lot of concerns about the finished look of the chip seal. They were satisfied with the chip seal performance, but the public wasn't always. They saw these roads as gravel roads or as dirt roads equivalently, and were always wondering, so when are you going to get around and pave my road? The county managers were a little bit stuck with that because they said, well, so what do we do with that? Do we pave it? How do we fix this? We presented them with a solution that said, look, you can extend the life of your chip seal and get a finish that the public loves with a fog seal. So they took the chip seal roads they worked with earlier that year and decided to fog seal a few of them to see how it would turn out. And as it turned out, once they got this fog seal down and cured, they had the public and even the neighboring county agencies asking, so when did you hot mix this road? How did you guys find the time to do that? And they just replied, oh no, this isn't hot mix, this is emulsion. This is what it looks like.
Thanks for sharing that. So just an example, again, of an agency's ability to say, what do I need out of this road? Can I recycle it? Is there an emulsion that will help me to do so? Do I need to restore friction? Do I need to keep the moisture out? Or in this case, it was a creative way to say, how do we help taxpayers be more satisfied with what they're seeing? And fog shows a very efficient and comparatively inexpensive way to make a road look more aesthetically appealing and quite frankly look like new asphalt. As I said, there's many more success stories on the website. What I want to do now is take you to the section of the site that answers more technical questions. So Grace is going to take us back to roadresource.org. And again, in the top right section or corner of the site, you'll see the header called Emulsions. And right here, you can click on the Emulsion Resource Center. This section takes you to really a technical menu. It's broken down by safety and handling, storage, pumps, other equipment, and then a big list of definitions. And really this section of the site is a combination of the major questions that agencies ask about emulsion specifically, along with the technical information that emulsion manufacturers and contractors have gathered over many, many years of operating specifically in that arena to say, here's what you need to know to be confident in using these treatments and to ensure success. So there's an overview here with a really great explanation of basically what is an emulsion, what do I need to know about safety, and just some high-level information. From here, we go into a handling section. And this is a lot of questions that agencies had about how to handle it. What do I need to know about different temperatures? What do I need to know about the temperature of the product as well as temperature of the air around me as I'm considering applying this treatment? Talk a little bit about compatibility here, anionic, cationic, different types of aggregate. As Grace mentioned earlier, there's also information about that in the naming and nomenclature section. In the storing asphalt for emulsion section, let's click on do's and don'ts. And one thing I'd like to share to agencies on the line, when we meet with emulsion manufacturers and contractors and we say, what's one or two things that you really wish your end user knew and understood about the product? One of the number one things that we hear is how to handle it, how to store it, when and how to test it. Simultaneously, that's one of the biggest questions that we hear from agencies when they're considering using more of these treatments. So this is a simple list of do's and don'ts, as well as storage temperatures for different types of emulsions. We have a fairly extensive section there on pumps, where we cover different types, sizes, installation, maintenance, and troubleshooting. The troubleshooting section is useful, and on any technical menu on the site, you'll see this, where we've had everyone say, what sort of troubles or frustrations or problems do you experience? Can we organize that in an easy way for a user to understand, what do I do if it's not pumping, if it's noisy, if it's got too much power? Next, there's some sections on other equipment, from storage tanks to heating tanks and tankers. We'll let you explore that on your own time. But lastly, we'll take you to the section around definitions. This is a really extensive section to help you bone up on nomenclature. So if you're newer to using asphalt emulsions, or if people are dropping alphabet soup or jargon that isn't as easily understood, this section has several pages of all kinds of different words that you're going to find as you use more emulsion-based treatments, and clear definitions about what we mean by those words. So with
Thanks,
that,
Lindsay. Sorry.
Yeah,
Thanks, Lindsay, for walking us through that. We find that those things tend to be really helpful in addressing specific questions about emulsions. But there's a lot of high-level stuff going on in the industry right now. We know that emulsion-based treatments are gaining traction in the industry. We're seeing more and more of those. Brian, do you mind walking us through a little bit about what types of trends we're starting to see, how people are using more emulsions and possibly why?
Sure. So we know that back in 2006, the last time a large-scale study was done in the U.S. and North America, 5 to 10% of asphalt was used for emulsions, and that's roughly still true today, trending more towards 10%, and hopefully going to keep increasing past that. But the more stark thing to note is that 65% of construction projects include an asphalt emulsion, which it can be deceptive. You don't realize how much tack coat, chip seal, and other things like that get done, and how much they factor into everything until you see a number like that. But 65% of construction involves an asphalt emulsion.
And so what exactly are the trends contributing to that sort of growing traction?
Well, I think ultimately it goes with agencies trying to find that extra life they can get without having to resort to expensive tools like hot mix to fix their roads. They'd like to be able to reclaim what's already failing. They'd like to be able to extend what's already good. They'd like to make use of things like cold recycling, reclamation, to repair roads that need fixes, but also to use things like chip seals and fog seals to extend the roads that are already good so that their network lasts and isn't just simply a cycle of replace and repair that, quite frankly, a lot of budgets can't sustain.
Yeah, and if you're interested to learn any more about extending pavement service life and how to manage a network proactively, we've got several webinars on that. And it sounds like, Brian, this is like the top line for most agencies. How do I make my dollars go further? And emulsions are just one more tool in that toolbox. So with that, we're going to get a little bit into new construction. We've talked a lot about extending pavement life. We're using the assets that you've already paid for with recycling and reclamation, but we haven't spent much time on new construction and the value of tack coat, sometimes called bond coat in the industry. Lindsay, would you mind walking us through that?
Sure. And I just like to say we see a lot of really good questions coming in the chat boxes, so we're paying attention to that. And once we get through, we're going to try to end our webinar about 10 or 15 minutes early and take some of those questions. So feel free to keep those questions coming in the chat box. So we'll head back to the Road Resource website, and we will talk about tack coat, sometimes referred to as bond coat. Yet again, this can be found in the emulsion section, and you'll click just under construction emulsions. There's an option there to explore prime, but today we're going to focus on tack. So the critical concept to remember about tack coat, and I'm going to leave most of the technical information here to Dr. Powell, who's going to be walking us through what he's seeing on the test track specifically related to tack. The critical concept here is that it's worth doing it right. Bond coat tends to make up 1% of your total pavement cost, but if it fails, fixing that can cost 30 to 100% of the original cost of construction. And there's been some really interesting research done around tack coat recently, partially due to some failures that happened on the NCAT track in 2013. There was some premature failure, and as they dug into why, one of the leading reasons for failure was insufficient bond coat. And what we're finding is that bond coat is more important than we ever realized, and we need more of it than we thought we did. From our perspective at Verios, we dug into, well, why is bond coat or lack of sufficient use of bond coat ever a cause of pavement failure, and what could we do to prevent it? We found that there were several things happening that are quite preventable. So if you look down there and you see what can prevent your road from failing, or how can you ensure that the proper amount of tack coat is used in every construction project, everybody plays a part. Contractors have to play their part, suppliers have to play theirs, and agencies have to play theirs. So we'll quickly visit this agency section here and see what did we find. And we found that in some cases, bond coat was listed as an incidental, rather than including it or speccing it as a pay item. And so for agencies, from your perspective, speccing that as a pay item and then inspecting against it, requiring bond coat inspection every time, is going to incentivize and ensure that success. We found that in states where bond coat was treated as an incidental, they were more inclined to have bond coat failure than states who specced it as a pay item. So that's just one thing, along with inspecting against it to ensure that what indeed you specced occurred. Are a couple sort of easy things that you can do to ensure that this is never a reason a road fails. There's a helpful little infographic there explaining the purpose of bond coat, but when it comes to something technical like that, I'm going to turn it over to Dr. Powell. We'll hop back into the webinar, and Dr. Powell, I so admire your work and appreciate the experience that you have at the test track, really seeing how to ensure pavement success. And I'd love for you to see or to help walk us through what you're seeing at NCAT as it pertains to tacking with emulsions. So we'll turn it over to you.
Thank you, Lindsay. Can you hear me okay?
We sure can.
Excellent, excellent. Well, as you mentioned, we've had several experiences on the NCAT pavement test track that have made us come to understand how important the tack material is between pavement layers. I think you guys are going to advance slides for me, so if you can go to the next slide. What I wanted to do in this presentation is share with the participants a recent experience that we had up in Minnesota. We have a national pavement research partnership, the National Center for Asphalt Technology, and the Minnesota Road Research Project. And back in mid-October, we took a two-lane road that is actually the access road for the Min Road Research Facility up in Albertville, Minnesota, and we set out to put many different types of treatments, both emulsion treatments and non-emulsion treatments, because we generate life-extending benefit data, essentially life cycle performance data for all the different treatment alternatives that are used by agency planners and agency engineers. And this is a picture of the road before the treatments were applied. So as you can see, it's this would be a really good road if you were responsible for restoring this road or for maintaining this road. You would probably say this road is a good candidate for reclamation only, but we actually wanted to go in and do full depth reclamation and do cold in place recycling and do central plant recycling and also do hot mix inlays, and then come back because this is the access road for a ready mix concrete plant, and there's a lot of raw material going in the right hand lane going away from the viewers, ready mix concrete trucks that are full coming towards us in this slide. So there's a lot of traffic on both sides of the roadway. So we were going to come back and put a 4.75 en masse inlay mix, hot mix on top of all these sections. So if you can advance to the next slide. This is a satellite view of where the project is located. Up in the top left-hand corner of this graphic, you can see one of the southeast loop of the Min Road facility. If you can hit arrow down to animate this slide, you can see that we paved, generally speaking, west to east on this road, and shaded in blue is a staging area there on the west end of that roadway. You can go ahead and go to that advance, and that staging area is important for our research, but also conceptually it's important for anyone who's responsible for doing this type of work. You really need to have a good place to set up all your equipment, to stage your materials, to make sure everything is working properly, do some calibration shots with rates and such. That's what we use this area for. We had tremendous corporate support from the pavement industry with donated equipment, donated expertise, and so we had this area to work with as we set all this equipment up, and then we also used it to make sure that everything was in working order and was going to perform the way we needed to perform. So if you can advance. So this is a picture of one of the full depth reclamation sections. being built, and we tankered in our engineered emulsions. What is inside that tank that you see plumbed into the reclaimer is an emulsion that's grade SB-EE, and that is an engineered emulsion that specifically is for full depth reclamation work. We did full depth reclamation, CIR, and CCPR using both engineered emulsions and foamed hot asphalt. For both of the FDR sections, as you can see in this picture, we had to spread cement at the required rate before we did our 7-inch deep cuts and blended everything together and graded it and compacted it. But when we did our CIR and CCPR sections with the engineered emulsions, we did not have to add cement to those designs because the emulsions were set up in a way with a modification package that made it possible to build without it. When we did our foamed asphalt, CIR and CCPR, we had to use cement like this. So with the CIR section with foamed asphalt, we also had to spread this type of cement. Advance the slide, please. So with all these sections in place, the FDR, CIR, CCPR, using both foamed asphalt and an engineered emulsified asphalt with a hot mix inlay comparison section, we came back and we placed a thin lay on top of all these sections, and we used an engineered emulsion for our tack material to bond between all the in-place sections and this 1-inch thick 4.75 millimeter in mass dense graded mix that we placed on top of it. The rate for this emulsion was actually 0.07 gallons per square yard, and that's with no dilution. That's with it delivered exactly as it was delivered in the tanker. And this is a cationic emulsion. That all the emulsions that we built with in Minnesota back in August were all cationic emulsions. But I like this picture because it shows how uniform and how well covered a good tack coat system needs to be. So if you can advance to the next slide. I love this picture. This is a great picture of a tack truck in a bar with properly set up nozzles. We got good flow of material, perfect coverage. The tack truck driver is lined up really well with the edge of pavement. We're actually doing this in the eastbound lane with live traffic on the other side under traffic control. So we got two-way traffic that is being maintained in that westbound lane. And also in this picture, you can see the pre-treatment condition of the roadway. So there's a lot of distresses on this road that we were working with. And if you look ahead, we're actually tacking back towards the paver. And the reason for that is because there's a four-way stop sign that is on the eastern end of this roadway. So we had to back up to that four-way stop sign and then tack back towards the paver. So for this reason, we actually had to stop paving and wait for this emulsion to break and to go from brown to black so that it was not, not too tacky and we could operate equipment on it. And it's important to not continue paving if the tack is not broken, especially with a small in mass dense graded mix, because the emulsion water, the water that's in the emulsion has no way to get out as that break and cure process occurs. Advance to the next slide, please. So the one thing that I wanted to show you that I felt would be useful for participants is this is one of the recycle sections that we built and tacked at that 0.07 rate. And we've got a material transfer vehicle and a paver that's coming in over it, and there's just a little bit of pickup of material, and that pickup is that's not just a tack pickup thing. What that is with some of the cold recycle mixes, they tend to kind of be a little bit crustier than conventional hot mix, and there's just a very small amount of pickup that's going on there, so it doesn't look as perfect as you would like to see a tack, but that's not a defect. That's just sort of an artifact of tacking and paving on top of cold recycle mixes. So that's not a catastrophe, and I just wanted to show people that so you know that sometimes things like that happen, and it's not a tack defect that's causing that to happen. It's just an artifact of the work. Advance. So there's the thin lay going down, and that's actually being placed on a control section where we didn't do anything to the road but broom it and tack it and pave it. But that's the thin lay mix that was placed on all the test sections on 70th Street there in Albertville, Minnesota. Really nice looking, very stable, very rich mix that did have 20% recycled material in it. So if you could advance to the next slide. Matt looked good behind the paver, and again, in this picture, we've got traffic in the other lane, but we paved this surface mix on top of all of our test sections going from west to east down to that stop sign, and then we turned around and went back in the other direction and moved the traffic control over. So if you advance to the next slide. That's a picture of what the finished and striped roadway looked like. So we had to open all of our sections to traffic overnight. We took our traffic control down. So the FDR, the CIR, and the CCPR sections, both with foamed asphalt and with emulsified asphalt, they had to support traffic overnight until we got traffic control back up the next morning. We didn't have any significant damage to any of the sections. And then we came back and placed our thin overlay at the end of the week and striped it. And as soon as we finished the thin overlays, as soon as we got done with our work, we put traffic on this road. Again, ready-mix concrete trucks that are going out in the direction of this picture with material supply trucks in on the other side. And we've seen excellent performance so far with all the different sections that we put in up in Minnesota back in August. So that was all I had, Lindsay.
Buzz, thank you so much for walking us through that. I love your perspective on seeing how these treatments perform in different environments and different climates as well. And for those of you guys who in your agencies frequently asking questions about research that's out there, if watching what's happening and coming off the test tracks is not a regular part of your practice, it maybe should be, or it's something that could help you understand the latest innovation and how the treatments are performing, because they continue to demonstrate some pretty impressive results. What I want to do now is turn it over to some questions. So I'm going to pitch these questions out to Brian and Buzz and let you guys answer them. So question number one, if you have additional questions, you're on the webinar, feel free to type them into the chat box. I'm watching that now. So we have a question, how long does it take to pass? We have about 15 questions so far, so we're going to answer them pretty briefly. But how long does it take to pass from breaking to curing?
How long does it take the tack to go from breaking to curing?
No, to pass, a general emulsion. How long does it take to go from breaking to curing?
I think that will vary with the grade of the emulsion. I would say you can have chip seals that can break and be ready on contact with their aggregate in a matter of minutes and then be ready for traffic shortly after they're finished rolling. But then when you look at your mixing grades, like in a certain sense, part of them never is completely tight because they're supposed to be able to be workable. And then for comparison, your quick sluts and your slurry have to be workable for an extended period of time. So I mean, it varies with the application. I would say depends on what you're using.
Thank you. And I'm going to take you, Grace, would you mind navigating to the Treatment Resource Center? Several of the questions that are being asked are answered there. So as you see the screen live here, you'll see Grace up at the top. Go to the treatment toolbox. Grace, do you mind going back up to the main menu? There you go. And you'll see the Treatment Resource Center. So that's where she clicked, and this is where, when we said there's 500 pages to this website, this is where the bulk of the content lies. So you can see her scroll down, and we do have a question on cold in place. So we'll click on cold in place. So 18 different treatments have a standard technical resource menu. So in each one of these sections, you'll be able to see process and variations, expectations, best practices, site selection, mix design in some cases, there's specification review, research and performance. So you can kind of find very specific answers to some of the questions that have been asked, and some of those will have information about breaking and curing. I have another question about tack coat. And so this question says, and Brian or Buzz, I don't know who's best to answer this, but once it turns black, should we wait more? Sometimes when the emulsion turns black, contractors try to pave over it, and then the tack coat seems to get removed by the shuttle buggy or the truck's wheel. So will it fix that if we just wait longer after it turns black? Will that solve the problem? Buzz or Brian, do either of you guys have insight on that?
I mean, I would go with the point that Buzz made, that sometimes with the surface you're paving on, that's just what happens, depending upon the surface you're paving on top of. If it's aged pavement or new construction you're paving on top of, typically the tack coat will tend to remain. But in cases where you have a more open, loose system, like something that was recently recycled or something that's heavily pulverized, the fact that the tack's also got to bind the pavement means that occasionally it will also bind to wheels.
I would add to that, Brian, for the benefit of the attendees. Sometimes when a project is not broomed the way that it should be, you can have more of a probability for tack pickup that way as well. So I mean, you can kind of do a field foot test on it. You know, if it goes from brown to black and it doesn't feel tacky to your foot, then it's probably going to be at the point where you need to go ahead and build on it.
We also see an increased use of trackless tack products, which I believe help with that problem as well. Is that correct, Buzz?
Yeah, that's correct, and that's a lower pin base asphalt that's used for that, for that type of product typically, and it does it tends to, or at least it can do a good job when it's used properly and handled properly. It can do a good job at reducing the amount of pickup on a project.
Thank you. Next question. On the emulsion naming page, you notice that there are 2 polymer letters. Can you tell us what the difference is between those polymer letters? Brian, do you want to take that one?
Yeah, just give me a moment here to bring up your website to make sure I see what you got on there.
Grace just brought it up on the screen if you're watching the screen.
Thank you, Grace. So the different polymer letters, so you have P for polymers, which can mean both polymers that are introduced as part of the emulsification process, but also emulsions that are manufactured with polymer-modified asphalt. You have, Grace, if you could click on these, I believe we have an explanation on some of them. Yeah, so polymers added, latex polymers added, which would be like a liquid suspension type. Those are the L situation in the naming is typically specific to asphalt emulsions, whereas the P is generally specific to polymer modified asphalt, but that will vary with the nomenclature an agency or specification chooses to use. Some of them use P and L interchangeably. Some believe that the P is only for polymer modified asphalt and the L is only for emulsified asphalt with polymers in it. And then the S, I believe, is for non-standard addition polymers that do not fall into either of those categories.
And I was just in Pennsylvania last week, and I know that across state lines, Pennsylvania and Ohio, I think, they use the same exact emulsion in one state uses a P, and in the next state it uses an L. And so sometimes that simply has to do with statewide nomenclature. So always contacting your supplier is going to be best. And many of the suppliers who are members at EMA have a technical support program where they're able to answer many of these questions. Grace, while you're on the website, will you just point out the Ask an Expert section, please? So a lot of the questions that we're getting asked, I'm afraid, are going to have a lot of the answer of it depends. We'll do the best we can to answer them, but as always, you can ask an expert here or reach out to your supplier, your contractor, who can typically provide deeper expertise. I'm getting another question. What is the modern, and I'm not sure if we actually will have an answer to this, so feel free to say it depends, but what is the modern ideal dilution percentage these days? In Sioux Falls, we use 70-30 for fog seal of CSF1H. And while we're there, do you have any insight on a cold-in-place recycling percentage? Buzz or Brian, do you have any idea or insight on that?
I'll let Brian answer that first, and then I'll answer.
Sure. Yeah, I was going to say, Buzz, if you can field the cold in place, I'll handle the fog seal. Thank you. So for fog seal, it depends on the base material. As you said, if it's a CSS, you want to dilute it down to a certain percent residue. Generally speaking, you want a residue of probably no lower than 38% on the finished application. I'm talking about the diluted asphalt. So if you dilute a 65% residue by 50%, you're only left with like 32%, and that's probably too low. Excessively low asphalt residues can cause it to cure kind of a brown or even kind of a mud-stained color, and also can generally indicate kind of a weaker ability to bind the chip seal as well. So you'll get both public complaints about why does my road look like mud, and then you'll also get inferior performance compared to the higher residue products.
Yeah, before we move on to the cold recycle, I'll add to that I'm not a fan of dilution, period, because my experience has been even at fog rates, when you've got a tack truck that's set up properly with the right size nozzles, you can shoot it without diluting it and still get the perfect coverage that you're looking for. And one of the two problems I've got with dilution personally are, number one, as you said, Brian, if you over dilute, you've got a problem. And then number two, you can have a situation where if you dilute, and if you begin to dilute and then you start commingling different products at different dilution rates, you don't really know what you've got in the tank. So for those two reasons, as a past state DOT employee and now sort of as a research builder, I'm not a big fan of dilution, because I think you can shoot without it. Now, what was the question about cold recycle again, Lindsay?
Thanks, Buzz. The question was, I think it was again about dilution and cold recycle. So I think that you would probably have similar feedback there. Is that correct?
Yeah, I'm just from a project control point of view and a project quality perspective, I'm not a big fan of dilution.
Grace, while I ask the next question, would you please get back to the Treatment Resource Center and navigate to the fog seal section? And I'd love you guys to see where some of these questions are, if not answered, you at least have some good resources that will help you get to the right answer for your area. This is a good question, Brian, for you, I think. What are the effects on original properties when an emulsion is subjected to a series of heating and mixing cycles to avoid sedimentation and long-term storage?
What is the impact on emulsion from heating and storage? So heat's actually good for the emulsion. A small amount of heating will generally help it when it's in a storage situation, will help it stay stable for longer. Once it's actually out in the field and in like a distributor, you want to make sure you warm it up, but not excessively, because in those kind of cases, the shear from the pumps and whatnot of the circulation can actually be bad for it. So generally speaking, you want to heat it moderately, never circulate it or pump it too much, and then always keep an eye on and take a look at samples of it to make sure that nothing's changed significantly. In cases like that, improper handling, like I said, can talk about things like settlement, but also heavy levels of pumping or letting it get too cold and then shocking it too much with heat can also generate things like sieve.
Another problem that I would add to that, Brian, is you need to have good communication with the contractors and the tack truck operators, because at the end of the day, tack truck operators, some of them like to suck back diesel fuel to clean their nozzles out, and when they do that and you have diesel fuel then that even in small quantities that can get in the tank, that can cause the emulsion to break down and cause sedimentation and all kinds of problems in the tank.
If I could add to that as well. Sorry, if I could add to that a bit, Buzz, that same issue also tends to be one of the reasons you'll see a sudden increase in tack pickup on jobs, is if you get diesel contamination in tack, it'll become so sticky that it'll pick up no matter what surface you put it on. So Buzz is absolutely right. Safe and proper handling of your cleaning and making sure you don't have any suck back into the material itself is essential for keeping it consistent across your job.
My suspicion, Brian, is that's a huge problem. I think that's a very widespread problem, and I think that probably has something to do with a significant amount of the pickup that we see on many of our projects across the country.
I would agree.
Getting a few more specific questions about emulsions. Can they be used in a spray paver for tacking beneath an overlay since it won't have time to break?
Can I field that one?
Yes, please.
Go ahead.
Okay. The spray paver concept was set up for gap graded mixes. That when you place them, the whole original concept was the break can occur, they can be a flash break under the heat of the mix. When you got 300 plus degree F mix placed on top of it, and the water will kind of immediately flash break out. That was the original concept. And one of the things that I'm particularly concerned about is now people are using spray pavers with dense graded mixes, and I'd like to see some data that says that we're not going to have performance problems, like, for example, stripping at the bottom of the asphalt layer because of the potential inability of the water to get out in a flash break situation, because smaller, finer mixes become relatively impermeable at lower levels of compaction, so you could have enough compaction behind the screed that the water just can't get out.
Okay. I'm going to ask you another question. In regard to tack coat, what effect does the base asphalt penetration grade have on bond strength? I see 0 to 20 pen for non-tracking to 100 to 200 pen for CRS1.
So
that might be a better question for Brian.
Yeah, I was going to say, so the penetration grade of the asphalt itself, in theory, even if you place like a 20 pen asphalt, when it gets exposed to the high heat of the hot mix itself, it will be softened by that heat such that it will form a bond with it. Excessively soft grades of tack tend to have more of a risk even when fully cured, or should they encounter some degree of diesel contamination, of sticking and creating messes or large-scale tracking on hot mix jobs. But as Buzz also mentioned earlier, there is also a certain degree of cleaning that has to be done to make sure you can have the perfectly engineered tack, but if the surface isn't properly prepared, it won't matter. I would say with pen grades, generally speaking, CRS1Hs, CSS1s, CSS1Hs, and CRS1s are all pretty much standard grades that are used. It's all about making sure you use them in the right way at the right place.
I would add to that, Brian, that I've talked to people who have concerns about using low pen asphalt as tack material up in the colder parts of the country, and to sort of test that theory, back in 2016, we placed some OGSC mix, hot mix, open grade friction course mix, up at the Monroe test facility, and we placed it on both asphalt pavement and on concrete pavement, and the expectation that a lot of people had was that we were going to see some kind of cold, brittle fracture issues with that tack material, and we never saw that, and it's gotten down to close to minus 40 degrees Fahrenheit, and it's still performing very well to this day. So.
Oh wow. We have a few more questions here. I know we're at the top of the hour, so Buzz and Brian, if you're okay, I'd love to field a few more questions. But before we do, I want to just remind you, on roadresource.org, on the home page of the site, there's a place where you can sign up for an e-newsletter, and we send out information about future webinars. Also, if you are on social media, consider following PPRA on Facebook and LinkedIn and Twitter. And we're regularly posting little bits and pieces about how to get the most out of this website. There's several updates planned through the end of the year. And again, mark your calendars for the October and November webinars on preservation and recycling. But Buzz and Brian, do you just have another 10 minutes or so to field questions for those who want to stay on?
Well, if you could throw the ones at me first, Lindsay. I actually have another meeting that I've got to go over to, another web meeting.
Okay.
So I'll take a few minutes and answer some quick questions.
Okay, sounds good.
That's good.
And let me quickly pull up the ones that are most relevant to you. actually, many of these could go to Brian, but let me see if you have any thought about this one. Can someone give us a more thorough explanation of the engineered emulsions used in pavement reclamation? I'm in San Antonio, Texas, and we typically have used MS1 or similar product. Is that one that you'd like to weigh in on, Buzz?
That's probably one Brian should answer. Ingevity put together all of our engineered emulsions that we used up at the Monroe facility recently, and I think Brian's probably a better person to answer that than me.
Brian, you feel comfortable weighing in on that?
Yeah, I can field that. So the concept behind engineered emulsions is that you get more strength and a faster cure and break compared to your standard recycling mixes. And the idea that, as opposed to it's less time you have to take to get the traffic off of it and less time before you can put successive treatments on top of it. The idea being that if you compare your non-engineered to your engineered emulsions, you're going to have more strength and better performance at a lower interval of time compared to standard mixes.
No, I would add to that also that one advantage of engineered emulsions is that you can potentially avoid the necessity of going back after you place the treatment and fogging it or priming it, just to kind of create a stable surface. With a good engineered emulsion package, that's supposed to be one of the benefits that it provides.
Thank you, Buzz. Honestly, I think a lot of the rest of these are things that Brian can field, so just stay on as long as you can, Buzz, and weigh in, and then when you have to leave, we thank you so much for your time.
Thank you so much, Lindsay and Brian and Grace. I enjoyed it very much.
We appreciate you, Buzz. In FDR applications, here's one question. What tests should be done during construction? The answer to that can be found on the Treatment Resource Center of the website. So I am going to skip that in the interest of time. Brian, we have a couple questions about this. When is the best time to add latex to emulsion and at which temperature?
The best time to add latex to an emulsion and at which temperature? Okay. So industry practices actually allow it to be added in a variety of ways. You almost never want to introduce it after you've hit the finished product. Generally speaking, you want to introduce it in the manufacturing process. It can be introduced as part of the aqueous phase, or it can also be injected into the asphalt itself as part of that manufacturing if you have the equipment for that. So, but realistically with those two options, you'll have consequences for either. Having it in the aqueous phase tends to hurt your emulsion viscosity. Having it in asphalt tends to increase your asphalt viscosity. A lot of it is a lot more material specific, so I'm afraid that's as close as I can get.
Okay. Here's another one about latex. Why do emulsions with latex generate lumps within the emulsion after you pump it?
So in some cases, and this is kind of a general question, I don't know that it's even necessarily specific to latex emulsions because I don't know what their specific experience is, but in some cases with emulsions that are less stable, because you have other suspended solids besides the asphalt itself, the latex itself can sometimes come out of suspension and create lumps. But generally speaking, you would see that. If you're going to see lumps in an emulsion, I feel like you would see it in almost any emulsion depending upon the amount of stress that's applied to it. In both cases, the systems are chemically stabilized and mechanically put together, so they should be able to survive the stress. I don't know that I would necessarily say that it's specific to latex emulsions, but cases may vary.
Okay. In our research, we have found that solvents greatly benefit workability and coatings with cold mix paving practices. What would be an effective replacement for the solvent to achieve the best workability and coating?
So if you wanted to use a mixing grade emulsion and you didn't want to use solvent, your next best bet would have to be something else that would come out in the mixture, because the whole benefit of solvent is that it gives you the workability, and then eventually it comes back out of the mix over time. But of course, there's always the environmental concern of volatile organic compounds. So in cases like that, depending upon what you're trying to control, if it has to be 100% solvent-free, like you can't use VOC-free solvents, there's other options available, but it would depend on exactly what kind of work we're talking about. If you're trying to get involved in just reduce your VOC production on the finished mixture, you could always switch over to VOC-free solvent alternatives.
Thank you. And then in regards to slurry seal emulsions, what does the presence of shot mean to you?
The presence of shot, is that the word?
Uh-huh.
S-H-O-T? Yep. Okay. So shot in the slurry steel emulsions, probably sieve. That's probably either grit that was in the emulsion that may have been generated from pumping, or may have been in it when it was in the tanker, or at some point became part of the emulsion. Shot in the mixture itself generally means you have asphalt coalescing in places it's not supposed to, so it can create rich spots that can become sticky in the finished mat. It can also create issues of pickup when you have the traffic on it as well. So I would say, generally speaking, try and avoid shot where possible. And ideally, you want an emulsion that's free of sieve, at least the kind that you can. If it's noticeable in your finished mixtures, and if that's what I'm reading by them saying shot, then at that point it's probably bad enough you don't necessarily want to be paving that, or if you do, you want to make sure you have some control over it to make sure that everything completely cures out. But if you have noticeable asphalt spots in your finished mat, that's probably going to pick up when traffic hits it.
And just make sure I'll remind you guys that there are sections on the Treatment Resource Center under every single treatment for troubleshooting and also for best practices, where the industry really got together to say what does it take, what are all the little tips and tricks, the things that an agency can do to ensure the success of these treatments. Just a couple questions. Merlin, you asked, how long was traffic closing time after fog seal application? Again, I'm going to direct you to the Treatment Resource Center for that. And close with this question for you, Brian. Last one. What is the most efficient way to clean storage tanks?
Okay. So if it's a storage tank that's being used for asphalt emulsions, your best bet would be to completely empty it as much as you can, open it up and get inside and manually clean it where possible. If we're talking about in the middle of a season, like let's say you've got to clean a tank out and put a different product in it, your best bet would be, it'll depend on the product, but your best bet would be to try and use some kind of a stable emulsion, like a slow set if it's anionic, or a cationic slow set if it's cationic, to try and rinse the tank out, and then you'll have to figure out what to do with that contaminated batch yourself. That's something you'll probably have to reprocess. If you're talking about cleaning out a tank that's completely fallen apart, like let's say it's got chunks of asphalt in it, and you're pulling material out of your line or out of your tank that's jamming screens, at that point, with that amount of asphalt, you've got to open it up and clean it out. It's become practice for some people to use things like cutback asphalts or highly stable emulsions to help assist in that cleaning process, but ultimately it's going to take some mechanical cleaning on the inside to get that kind of material out. Hopefully that's enough information for them.
Okay. Brian, thank you so much for your time today. All of you who joined us, looks like we had about 200 people with us today. Again, this webinar will be loaded on the website for you to review in future. And hopefully we'll see you at the next webinar in our series on October. Thank you very much, all.
Thanks, Lindsay.